Okay, we got a bunch of questions in this problem. And we're going to take a look first is what this thing looks like on a graph, okay? So, and really, you can see all we're really interested in for most of these is 2, because that's where this thing splits. That's where the joint is. So, well, let's answer A and B first, I guess, before I get into all this graphing stuff. So, as x goes to 4, f of x should be approaching, well, at 4, we are entirely on this interval here, okay? 4 is greater than 2. So as x approaches 4, f of x just is 2x minus 3. So f of x is approaching whatever 2x minus 3 is approaching. So as x goes to 4, 2x minus 3 approaches 5. So that's the answer there. As x goes to 0, well, 0 is less than 2, so we'd be in this function here. As x goes to 0, f of x should be approaching whatever x squared minus 2x plus 1 is approaching. That's 1. As x goes to 2 from below f of x. Well, now let's talk about this graph here. So 1, 2, 3, 4. Let's look at these here. As x goes to 2 from below, well, that's numbers less than 2. So 1.9, 1.999, 1.99999. As we keep getting closer to 2 from below, we would still be on this function right here, because these are values less than 2. So we'd be on x squared minus 2x plus 1. Well, at 2, this thing equals 1. So at 2, yeah, that's right, equals 1. Okay. This is actually x minus 1 squared, so that just moves it 1 to the left. I'm drawing a total blank here. 4 minus 4. That's right. Oh, because it's... oh, my. That was awful. I apologize for that. At 2, it's at 1. There we go. And actually, this graph, x squared minus 2x plus 1, this is why I was having a hard time. I had to point the wrong place. It really looks like this. It's a parabola that should keep going up here. It should keep doing this. But our function f of x stops this parabola. It stops being on the parabola at 2. So that's what's going on there. Let's get rid of all those guys. All right. So as x approaches 2 from the left, this is what this function looks like. Now, you don't have to graph it. You just have to understand that you are looking at values on this function. And it's approaching 1 from the left. As x approaches 2 from the right, now we're looking at values a little bit bigger than 2. So it would be in this domain right here, x larger than 2. As x approaches 2 from the right, we'd be on this function, 2x minus 3. Well, 2x minus 3 at 2 is 4 minus 3 is 1, and then it has a slope of 2, and it just kind of goes off. So it's over 1, up 2, over 1, up 2, and it looks something like this guy. Okay? So as x approaches 2 from the right, we're on this function, and this is approaching 1. So we get that. So since the left-hand limit and the right-hand limit are the same exact thing, then the limit as x goes to 2 is 1. And when they ask, is f of x continuous at x equals 2? Well, right now our notion of continuity is just that this graph has to be one piece. It doesn't have any jumps or anything like that. And it is. I can draw the whole thing without picking up my pencil because these two functions meet at 2. So the answer to this is yes.